Hi there, data structures. So today we're going to be doing something a bit different for Monday, and that's I want you to come in prepared to work on an exercise. And to do that, you're going to just have to watch these videos before you come to class. Hopefully you have time to do that. These videos should be about 15 minutes apiece, and then we'll have something to work on. So what I'm going to go over is how do you build a binary tree. In other words, and so we're going to write the binary tree class. We're going to do all the basic functions in them, the search, the add, the remove. And then we're going to go ahead and we're going to use what we have to basically solve some problems on Monday. Okay, I'll fully admit I'm playing a bit of this by ear, but hey, this has been pretty successful in my 1068 class, so we'll see how this works out here. So first thing you want to do is create a binary tree class in Java, and this is going to be taking in so the big thing about binary trees, if you remember, they have to be sorted, or they keep their data sorted, which means the data has to be sortable. So it's not going to be a binary tree of just anything. It's going to be a binary tree of extends comparable E. So in other words, things that can be compared to others of the same things. So this just simply ensures that anything that puts into the tree has to be comparable. So it will be like integers or doubles or strings or anything that can be comparable. Anything that has an order and can be put into an order. So that's all that does. And this ensures that basically we don't really have to retype this anywhere. So the next thing we have to do is let's define our node class, which we did in class at some point. So private static class node, and this works just like the class we have in the class that the node class we created in the double linked list. So and that is that we're going to have a node E, and remember we don't need to do this whole extends comparable E over here. We don't have to rewrite that. We just have the node E over here. So node E left, then that will be the left node. Private node E right, and that will be the right child. So left child. So child, and then now if you remember from last week, which was like forever ago, remember these are recursive data structures. So for every single node, we're going to treat that node as though it was the root of its own tree, or subtree to be more exact, because there'll probably be the root of its own subtree. So this is not only the left child, but this is the root of the left subtree, and this is the root of the right subtree. Okay? So everybody is the left and right. Okay? Next, we need a place for the data. So private E, we called it item last time. You can call it item, you can call it data, you can call it whatever you like. Call it item just to be consistent, or inconsistent with what I did in class. So let's create a constructor, public node E item. This dot item is equal to the item that was just passed in, just like we did for the node class. So this isn't anything different. So now let's talk about what kind of variables we need to create the binary tree. What kind of instance variables? Well, binary trees, we need just like we needed a head for the linked list. So that's probably a good place to start. So we'll have a private node E head, assuming it can spell, and that will represent the node that's the head of the linked list. Very tired child. Private int size. Remember, so we're going to keep track of how many nodes we actually have in this binary tree. Oh, right, we don't want the head there, right? I was distracted by the crying, so we want root. We're going to call it the root, which may admittedly lead to some confusion later on, because we're going in our methods, we're going to call the node that we pass in the root, which will signify the root of a subtree. This root is the root of the whole tree, though. So I'll remind you of that. And for right now, that's pretty much all we need. We just need to keep track of the root, and we'll just keep track of the size, just simply so we can easily return the size. Let's go ahead and do that now. Public int size return this dot size. Okay. So that's pretty much what we need for right now. So what are the methods that we need to create in order to have a functioning tree? We need a couple. We need a bunch of other. So we need a bunch of methods. We need a few that are going to be annoying. We need public string toString, which we can't really test because it's going to be used to test everything else. Okay. And then we'll need a public void add item, public void remove item from the tree, and public void boolean contains item.